In today's topic, we'll see most unclear thing in electrical engineering, that is winding. There are mainly two types of windings. One is Grammy ring winding, that is, we'll have a ring like this. Okay, this is a hollow ring, and there is a conductor's winding will be placed, this fashion. So throughout this, winding is given. I think you could see the picture there. Now another type of winding is drum type winding. Like we'll have a cylinder, zoom, we'll have a cylinder here. Now in these slots, conductors will be placed, like winding will be given in this way. So it is distributed, winding is distributed here. So this is a drum type winding. So once the winding is done, this will look like this. It's winded, and we have commutator. Connections are there from here to commutator. Now we are splitting it here. I just cut it here and spread it like this. So as you see, in the down side we have commutator. So this down end we'll call it as commutator end. And this commutator, from this commutator we'll take the current, or we'll give the current if it is a motor. So this end we can also say front end. We can also say this commutator end as front end, and this end is back end. Alright. So this is drum type winding. We always use drum type winding, so our focus is now mainly on drum type winding. Next, second important aspect, number of turns. We'll go for winding like this. Let's take this as a winding. Okay, I'm giving winding in this fashion. This is one turn. I made one turn. This one turn is having how many conductors? 2 conductors. And this number of turns is always an integer, because we cannot have half a turn or a quarter turn like that. We'll have some integer number, 1, 2, 3, 4 like that. So if number of turns, that is n, is an integer, one turn is having how many conductors? Yes, 2 conductors. So what is the relation between number of turns and number of conductors? Z is equal to 2 into n. So if you multiply any integer with 2, you will get an even integer. I am multiplying any number, any integer number with 2, you will get the result is an even integer. So Z is always an even integer for any type of winding, not only DC machine, AC machine, any type of winding for that matters. Okay, so if I continue the winding, one coil is there, I am continuing winding like this. So here I'll connect this point to commutator. Okay, this is connected to commutator, and winding is going further. So one commutator segment is connected to how many conductors? Yes, 2 conductors. Which means, what is the relation between number of conductors and number of commutator segments? Yes, number of commutator segments equal to number of conductors by 2, or number of commutator segments equal to number of turns, simply. Alright. Next one. What is pole pitch? Before going to that, let's see what is pitch. I think if you are aware of cricket, pitch in cricket is called what? Yeah, distance between wickets, 2 wickets. So how much is the distance? 22 yards, very good. So here pole pitch means distance between 2 consecutive poles. Pole pitch means distance between 2 consecutive poles. So now in case of cricket we measure that in terms of maybe yards or meters. But here, how do you measure the distance between 2 consecutive poles? Do you measure in terms of kilometers or meters or centimeters? No, we measure in terms of number of slots, or maybe number of conductors. People may use anything. Okay, so how is it different from measuring from number of slots and number of conductors? So if you see, anyways, we'll discuss that a little later. So what I'm saying is, pole pitch is the distance between 2 consecutive poles. That can be measured either in terms of number of slots or number of conductors. So I'm representing like this. S, green is for number of slots, number of slots per pole, or you may say number of conductors per pole. Both are right. Somebody may use this, some may use this. I prefer to use number of conductors. Okay. Next one. This pole pitch, if you know the operation of DC generator, this pole pitch is equal to 180 degrees electrical. Okay. It's always one pole pitch means 180 degrees electrical. From the operation you can understand this. Just go through the operation of DC machine, DC generator, you'll get the point. Next one. What is coil span or coil pitch? There is a coil here. This is one coil. Alright. This is one coil. What is the coil pitch? The distance between these two. You may say this is one conductor or this is a coil. So this is one coil side, this is another coil side. You may call it as a coil side or you may call it as conductors. So what is the distance between these two? 1, 6. 6 minus 1 is? Don't get confused here. Distance between these two in terms of slot means don't count these slots. 4 slots, so 4 is the distance. That's wrong. Because if somebody is asking you what is the distance between 0 centimeters and 5 centimeters, what would you say? The distance is 5 centimeters. If somebody is asking what is the distance between 1 centimeter and 5 centimeters, then answer is 4 centimeters. So here, distance between the same terminology you should use here. Distance between 6th slot and 1st slot. How much is that in terms of slots? 5 slots. 6 minus 1 simply. Alright. So that is coil span. And this coil span, we should maintain this coil span. We should try to maintain this coil span to be close to 180 degrees. We should maintain coil span should be equal to pole pitch. We should try to maintain, okay, for the better addition of voltages, if it is a motor, for the better torque production. Which means, if this conductor is under north pole, this conductor must be under the influence of south pole. And here this must be under north pole, and this must be under south pole. We should try to maintain that. But of course, it's not always possible. Next, what is the type of windings? So this winding, how this winding is looking like? A wave shape. So this winding is called as wave winding simply. Because it is looking like a wave, it is called as wave winding. Now to make such a kind of winding, to make this structure, what are the details you require? I require this distance, back end distance. That is what we will call it as back pitch, YB. Again, the measurement can be in terms of number of slots or maybe number of conductors. Okay. So how many number of conductors in between these two? Or how many number of slots in between these two? Again, in between means don't count these. Just say 6 minus 1. How much? Yeah, 5. Okay. Next, we should know this distance. What is this? Front end. So this distance is called as front pitch. Alright. How much distance is that? 1, 2, 3, 4, 5. Or 11 minus 6. 11 minus 6 is 5. Again, this will be 5. Again, next this will be 5. So if I have the information of back pitch and front pitch, you can understand, you can draw the winding. Are you clear? Next, another one is called winding pitch. Okay, winding pitch is simply distance between two consecutive coils. This is first coil and this is second coil. What is the distance between these two? This is the distance. 11 minus 1, that is 10. Or else you can say YB minus YF, sorry, YB plus YF is equal to winding pitch. I'm talking about wave winding. Okay. Now, can you tell me from here, YB, can it be a fractional value? No, it can never be a fractional value. It is always an integer value because it is a count, number of slots. It is always an integer. YF is also an integer. It is always true. Okay. Next one. We have another pitch called average pitch. What is average pitch? It's simply average of front pitch and back pitch. That is YB plus YF by 2. That's it. Average of front pitch value and back pitch value. This for any type of winding it is true. Alright? It is true for wave winding. Now let's go for another type of winding. So now, instead of doing this, let me take this back in here. I'm connecting this to commutator segment and it has gone like this. Means the second coil is overlapped onto the first coil. Hence we'll call it as lap winding. So to draw the lap winding, what we require? This is a back pitch, it is already there. And front pitch, this value. Okay. And this is front pitch. Front end. So these are the two types of windings. Now, if you see here, I'm making coil like this in this fashion. Coil I'm turning this way and winding also moving this way. Hence it is called as a progressive winding. Alright. Now what is a retrogressive winding? I think I forgot to say winding pitch here. What is winding pitch here? Distance between two consecutive coils. What is the distance between these two coils? This is the first coil and this is the second coil. Distance is 2 minus 1, that is 1. So in case of lap winding, winding pitch equal to YB minus YF. Alright. Now we have a retrogressive winding. Okay. Now instead of keeping it here, what if I do after this first coil like this? So I'm turning coil in this direction, but winding is moving backwards. Okay. So this is called as retrogressive winding. In case of retrogressive winding, YB is less than YF. In case of progressive winding, YB is greater than YF. Which means you can understand now why this winding pitch named as winding pitch. Okay? Because by looking at this winding pitch, we can say what type of winding is that. Suppose if winding pitch is negative, then we'll call it as a retrogressive winding. It is clear. If winding pitch is positive, then we'll say it as progressive winding. Of course, if this winding pitch is less than the pole pitch, then it is a lap winding. If the winding pitch is more than pole pitch, then it is wave winding. So this winding pitch is helping us or indicating the type of winding, hence it is called so. There is another pitch called commutator pitch. We'll discuss that later. I hope now progressive, retrogressive is clear. Now what if I go for wave winding? In wave winding, what is progressive and what is retrogressive? Let's see. So wave winding, I'm continuing this way. Okay. So after this, winding will go and it will continue here. Okay. Winding is continuing from here. Can you see? Yeah. Means after this winding, it has started again after this. After the first one, it has started. So that is called as progressive. What if it would have started this side? Yes, it is called as retrogressive winding. Are you clear? Very good. Now, let's find an interesting factor here. One important observation. So this is back pitch and front pitch. So total this is one winding pitch. Okay. And we have here back pitch. Again there will be a front pitch. That will carry, somewhere over here maybe. So this is a back pitch. Another front pitch is here. So that will be giving us another winding pitch till this. Now tell me, what is YW1 plus YW2? Again, in terms of slots. You tell me in terms of slots. If total number of slots are S, how many slots are there? If I add these two, how many slots do I get? Total number of slots are S. Again, it has started after the first one. So S plus 1. Green color means number of slots. Alright. Now how many number of poles are here? 4-pole machine. I'm talking about 4-pole machine. Alright. So if it is a 6-pole machine, then if it is a 6-pole machine plus YW3, you will get 3 things, 3 winding pitches will be equal to S plus 1. Alright. Now for a retrogressive case, it will not end here. W1 plus W2 will be ended here itself. Alright. So in case of retrogressive, this is simply minus 1. I hope this is clear. Next, what if I want to represent the same in terms of number of conductors? Okay. Because some people do also represent in terms of conductors. So total number of conductors in place of S, I am writing Z. Plus or minus. Plus is for progressive, minus is for retrogressive winding. And in place of 1, yes, if each slot is carrying 1 conductor, then this will be S, simply 1. What if each slot is carrying 2 conductors? Then we'll have to keep 2. What if each slot is carrying 4 conductors? Then it will be 4, like this. Here also same, Z plus or minus 2. Okay. Now here, in general, how can I write this? In general, I can write this as YW into P by 2. Because we know these two are equal. How many are there? 2 are there because we have 4 pole. That is 2 pair of poles. If I have 3 pair of poles, that is 6 poles, then we have 3 terms. So in general, I am writing YW into pair of poles, which is equal to either S plus or minus 1 or Z plus or minus 2. This is valid only if the number of conductors in each slot is 2. This is valid only if number of conductors in each slot is 2. Because that is what we normally use. That's why I am specifying that only. I hope now you understand what is progressive, what is retrogressive in case of lap and wave. Now, there is another thing called singly re-entrant and doubly re-entrant. Or before we go to that, I think we missed to see multiplex winding. Okay. So far we have seen simplex winding. What is duplex winding? That's interesting. Okay. So here what we have done? After that, either I am continuing here, right? So instead of putting it here, what if I leave 1 slot? I left 1 slot, I'll continue the windings. Then after one complete circle, then I'll come to this in continuation. So what is the distance between these two slots? 3 minus 1, that is 2. Hence we'll call it as duplex winding. What if I use, or what if I skip 3 slots like this? 4 minus 1, that is 3, triplex winding. If it is next, quadplex winding. Okay. In case of lap, if I place it here, it is simplex winding. If I place it here, it is duplex winding. And this is triplex winding. And quadplex, something like that. Alright. Now, what is singly re-entrant, doubly re-entrant? And this singly re-entrant and doubly re-entrant is there only for multiplex winding. Okay. So let me take duplex winding. This is duplex lap. Doubly re-entrant means I'm going for winding. Duplex winding is going like this. And after all these things, it has ended here. This is left over. They're left. One slot is left in between and winding is ended here. Now what I'll do, I'll place another set of winding, another fresh winding, another fresh wire I'll start winding here. So there will be 2 independent winding sets will be there inside. That is what we'll call it as doubly re-entrant winding. What is singly re-entrant winding? So winding is going like this, but it is not ended here, it will continue here. Okay. After one complete circle, leftover slots will be continued. I hope now these things are clear. What is the first one? Number of conductors is always an even integer. Number of commutator segments is equal to number of coils. Okay. And back pitch and front pitch, they are always an integer. Alright. Progressive winding, retrogressive winding, that is clear. Simplex, duplex, and singly re-entrant, doubly re-entrant. So now one thing is left, that is double layer winding. What is single layer winding? What is double layer winding? Double layer winding means there are 2 layers. Don't think that each slot is having 2 conductors, then only it is double layer. No. It's just 2 layers. Maybe 4 conductors, 2 are on the upper layer, 2 are on the bottom layer. That is also a double layer. 4 conductors per slot. But it is a double layer. Alright. Even 2 conductors, they are placed in 2 layers. That is also a double layer. If only 1 conductor is there, or maybe 2 conductors are placed side by side, that is also single layer. I hope now you understand what is double layer and what is single layer. We normally use double layer winding. Double layer only we frequently use, and duplex winding. But throughout our analysis, we look at, maybe further lectures also, we look at double layer simplex windings only. Okay. Thank you for watching. Please like the video and share your comments. Don't forget to subscribe to our channel for more such videos. Thank you.